Assalamu alaikum. In today's class, we'll talk about beams. Have you heard about beams? Do you know something about beams? I'll make you familiar with the beams and what for it is used and how does it work and how it resists different loads. So let's start learning together about beams. So first of all, you should know that beam is a structural member. So one important thing about beam is that it is a structural member. It's mostly placed horizontally. So, and important thing about beam is that it carries loads. I'm making you familiar with the beam. It carries loads, and the most important among them, it resists. It resists. What it resists? It resists shear force, that is SF. It resists bending, and the most important, deflection. So that is the job of a beam. It resists these three important things. Now understand more about beam. What does beam means and how we use it? So if you see a beam, as I said, it is placed horizontally. So assume this a horizontal member is a beam. So because the position is horizontally, so assume this as a beam. Now the opposite of beam is, which is also used in structures, that is column. That is column. So column, only the placement is different. It is placed horizontally and the column is placed vertically. Now the most of the things are similar, like it is being used in structures. Yes, column is used in structures. It carries loads. Yes, it carries loads. Both are being used in structures. Now, would you like to know more about beam? Because the topic is only beam, not the column. Now let's try to find out more about beam. Determinate beam, and another one is indeterminate beam. A beam which can be proven, analyzed on the basis of reactions is determinate beam. You'll come to know what does reactions mean. And opposite of that, which cannot be analyzed on the basis of reactions, that is indeterminate beam. Now, as I said, there are major two classifications. Now, each classification has its own types. So let's try to know first statically determinate beam. What are the various beams which are statically determinate, which we can analyze, which we can evaluate on the basis of reactions? So the first one is cantilever. Cantilever beam. What is a cantilever beam? The first of all, what I told you earlier, that a beam is a horizontally placed. So let's say a beam, this is a beam which is horizontally placed, and you know it has two ends, one end and another end. It has this end and this end. when one of its end is fixed, inbuilt in the support or in the wall, and other end is free. What does I say? I mean, if I fix this end of the beam, I fix this end of the beam and the other end is free, that type of beam is called a cantilever beam. What's the cantilever beam now, my dear students? A cantilever beam is a beam whose one end is fixed or inbuilt in a wall or in a support and the other end is free. That beam is called a cantilever beam. Now, there are other types that are statically determinate, that is simply supported beam. As the word indicates, simply supported. How many ends are there in the beam? 2 ends. On the 2 ends there are 2 supports. They are not fixed. They are not inbuilt. They are just on the 2 supports. So this is a beam. If this is a beam and 2 supports beneath, 2 supports beneath. So this beam is resting on 2 supports. A beam whose 2 ends are supported on 2 supports is called a simply supported beam. So these 2 are the supports. So that type of beam is called simply supported beam. There is one more beam in the category of statically determinate, that is overhang beam. That is the third type. That is overhanging beam. Again, we'll go with the same. Overhanging means the other end is overhang. The other end is overhang. So it could be like this. This is a beam. So there are 2 conditions. In overhanging beam, there are 2 conditions. What are those conditions? One end is on the support, like this, and the other support is somewhere away from the other end. So what does this mean? This portion is overhanging, isn't so? Yes, this portion is overhanging. This is the condition 1, when one end of the beam is overhanging. The condition 2 could be both ends are overhanging. The condition 2 could be a beam. Now the overhang is not only the one end of the beam, the overhang is on both sides. So this side is overhang and this side is overhanging. So that type of beam is called overhanging beam. A beam whose supports beneath the beam are away from its ends. Away from its ends is called overhanging beam. So these are the 3 major types of statically determinate beam. Now let's talk about indeterminate beam. So what are those 3 types? Now we'll talk about a beam which is indeterminate. So the first type is fixed beam. As word indicates itself that fixed, the 2 ends of the beam are fixed either in the walls, either on the supports. So if this is a beam, which beam? Horizontal beam, and its both ends, if it would have been this, it would have been determinate beam, cantilever beam. Now the both of its ends are fixed in the supports or in the walls, then it is called fixed beam. Now one more condition, that is propped cantilever. Propped cantilever beam. You know what is cantilever beam? A cantilever beam is one whose one end is fixed and the other end is free. This is the cantilever beam. But this propped cantilever beam is one whose other end is in on the support. So this end, the other end which was free, now it is no more free. So there exists a support beneath like this. So that type of beam is called propped cantilever beam. So propped. So it's propped cantilever beam. Which is a propped cantilever beam? It's a cantilever beam. What is cantilever beam? A cantilever beam is one whose one end is fixed, other end is free. Now propped means the free end has a support beneath. That is a propped cantilever beam. Now one more type, and the last type of it is continuous beam. What is a continuous beam? A continuous beam is a beam which has more than two supports beneath. A beam like this is a beam. So if it would have been like this, a support and another support, then it would have been which beam? Simply supported. Now I am saying a continuous beam is a beam which has more than two supports beneath. So it has maybe three supports or more supports beneath. A beam which has more than two supports beneath is called continuous beam. So that is about types and classifications of beams. Now it has one more important topic. Before starting the numericals, I am making you familiar with the theoretical concept of the beam. I hope you will enjoy. If you enjoy, please do subscribe, also press the bell icon, and also share with your friends and colleagues so that I can make more such videos in future for you. So now I will talk about the loads, because you know that job of a beam is to carry loads. Yes, it carries loads. So what are the various types of loads it carries? Remember, my dear students, number one load a beam carries is point load. It is also called concentrated load. It is also known as concentrated load. The second load it carries is UDL, uniformly distributed load. And the third type of load a beam carries is UVL, uniformly varying load. It's also called triangular load. What does it mean? What are its representation, graphical representations? Let's try to understand now this concept, because that is the main job of a beam, that it carries different types of loads. Now you are well aware about the beam. If I put like this, so you know it's a beam, okay? Now let's say it is a beam whose one end is fixed. Which type of beam I'm making? Yes, I know you said cantilever beam. Now it carries loads. Let's talk about point load. Like point load, this is the graphical representation of a load. A load is acting on the beam. Like maybe here and somewhere here. So a load which is acting at one single point. Which is a point load, my dear students? A point load is a load which is acting at one single point. It is not spread over the area. It is acting, concentrating at one single point. That load is called point load. And its graphical representation, it is represented like this. A line, then arrowhead downwards. So when it is on the beam, you have to clearly say, yes, this is the point load. And its load, its units are either in Newton, kilonewton, and so on, maybe tons or kgs, and so on. That is the unit of the point load. But in real practice, let me make this statement here. In real practice, every load occupies some space beneath. But for the sake of calculations, we are assuming that it acts at one single point. Otherwise, theoretically there is a point load, but practically there is none. But for the sake of calculations, we say it is a point load. Now, as I said, the another one is the UDL, that is uniformly distributed load. Same beam I will take again. I will take same beam. So you know now this beam is the which beam? Yes, you are right. It's a cantilever beam. Now the load is uniformly distributed. When a load is uniformly distributed, that means it is spread over the area of the beam, over the cross section of the beam. That means if I say like this, it is being represented like this. How we can distinction? Yes, now it gets distincted. So this is either the graphical representation on this portion. Let's say this portion was 2 meters. So there is a beam which is left. This portion, maybe it was 1 meter and this was 1 meter. Now there is UDL. So there is a UDL spread over on the 2 meters of the beam. So it is uniformly, how much is here? It is same at each and every place. This is the one of the graphical representation. Another graphical representation of UDL is like we show it like this. So you can either show like this UDL or like this. So again, it's a load but spread over on a particular area. It occupies some area beneath. So therefore the units could be kilonewton per meter. Or here it could be kilonewtons per meter or so on if the units are changed. But it is spread over on some distance of the beam. So that is called uniformly distributed load. This is the graphical representation. Now the third one is UVL, uniformly varying. As you get with the term, the load is continuously varying. It's gradually increasing or decreasing. So this could be the graphical representation. Now it is 0 at this point and maximum at the other end. So here the load is 0. So at the one end it is 0, and at the other end it is maximum. So the load is uniformly varying. That's why it's called UVL, uniformly varying load, or gradually varying load also. So, or it makes like a triangle, it looks like a triangle, that's why it's called a triangular load. So these are the various names by which we call the UVL. So again the unit is, again it's separate over the area, so unit could be kilonewton per meter. So these are the various types of load which a beam has been made to bear. There are other things also which we should know about the beams. That is, as I said earlier, it has been made to resist. So as I said earlier, that beam has been made to resist SF. SF stands for shear force, and it has been made to resist BM. BM stands for bending moment. So in this topic I will focus on only these two. Otherwise it has been also made to resist deflection, but this topic does not contain that. So I will focus on the shear force and the bending moment. What does it mean? So what does shear force then means? It has been made to resist. Let's assume this is a beam. Let's assume this is a beam, and it's a cantilever beam, as you know, and there is a load of 100 kilonewtons acting at that point. Fine. And there is one more 200 kilonewtons acting at that point. Now what this load tries to do, to shear the beam at these particular points. In other words, we can say it will try to break or make a failure in the beam in the form of a shear force. So this force is trying to cause the injury to the beam. So that means if a load is acting here and load is acting, let's assume only one load is there so that you can get it clearly. So what will this load try to do? This load try to do to slide this portion. This is the right portion, to slide the right portion downwards. The beam's right portion will slide downwards and the left portion remains at its own position. So that is what the beam is not allowing, my dear students. This is not happening. This would have happened if the load is, the beam has not been designed properly. This will happen. So if this is the case, the right side will slide downwards and the left side remains at its own position. So like it remains at its own position, then we take the sign convention. Then we take the sign convention as positive. You are getting me? I will make you familiar in future classes about this, the sign convention. So the opposite could be now this load is not here. Maybe a load comes from this end. So what will happen? Now this portion, the right portion will go up. It will go like this. The right portion will go up. It will slide upwards. The right portion slides upwards and left remains at its own. Which is doing this? This shear force. It is a tremendous force which is trying, this beam is trying to resist, oppose this shear force. Beam is not letting this happen, my dear students. So in that case, the vice versa. See, this is right side goes down and left remains at its own. Now it goes up and it remains at its own. We have to take the sign convention vice versa. That means negative. How do we use that in numericals? I'll make you familiar with that. Okay, so this is about the shear force, and the shear force is the sum of algebraic. Remember this thing. What is shear force? It is sum of all the forces acting either or left or right of the beam. The shear force is the algebraic sum of all the forces acting either on right or left of the beam. That is the SF shear force. Now let's talk about the last one. Then in the other class I will talk about the diagrams of SF and BM. That is BM. As I said, BM stands for bending moment. In bending moment, if we take like this, a beam. So bending moment means if I apply a force in this direction and in this direction, what will happen to this? So this is which direction? Which movement is this? This is clockwise. And of course, this is anti-clockwise. When the right side has anti-clockwise movement and the left side has clockwise movement, it will try to bend the beam like this. It will try to bend the beam like this. So this is called sagging. So it sags the beam like this. In such cases, we take bending moment as positive. And opposite could be, again here, the opposite could be the beam is like this. Now, a movement comes like this and like this. We are doing it like this. And this one is anti-clockwise. And this is clockwise. So when the right side of the beam has the clockwise movement and the left side of the beam has anti-clockwise movement, at that time it will be like this. Beam will be like this. So this is called hogging. It is opposite of sagging. So sagging is like this and hogging is exactly opposite of the sagging. So this hogging at this time of point, we have to take the sign convention as negative. So BM has to be taken as negative. Now question arises here, what does BM means? Again, BM is bending moment is nothing, it is the algebraic sum of all the moments. Remember, my dear students, BM means algebraic sum of all the moments either on the right or left side of the beam. So I have made you aware about the theoretical concepts of the beam. In next class, I will come up with the numericals. Till then, fi amanillah. Take care.